There's one last concept I'd like to cover from section 5.1, and that is the idea that we can calculate area. Well, kind of. So let me show you what I'm talking about. We're going to use a double integral, which we've already established is a calculation for a volume. But we're going to use that double integral to pretend like we're calculating an area, and it's going to give us the right answer. So the reason why this is going to work is because we're specifically setting up a double integral so that the function that we're integrating underneath gives us a height of 1. So if you think of a box, if you were to calculate the volume of this box, it would be the area of the base times height. But if the height is equal to 1, then you're really just multiplying the area of the base times 1. Now technically it's a cubic units, and area is square units, so we're going to fudge it just a little bit. We'll calculate a volume. It's going to have the same numerical value as the area, and we're going to manually adjust the units. So if we want to do an example, we can consider the function, the region, the rectangular region that goes from 0 to 3 and 0 to 2. Now we already know that this is just a rectangle from 0 to 3, 0 to 2. We can find the area of this rectangle. It should be 6. 6 squared units. But let's see if we can use this new iterated integral to figure this out. So we're integrating under the constant 1, and it doesn't matter which variable we integrate with respect to first, so I'm just going to put y second. X is from 0 to 3, y is from 0 to 2. If we integrate with respect to x first, 1 turns into x. X is evaluated from 0 to 3. Let me carry around my other notation here. If I evaluate x between 3 and 0, it just comes out as 3, so I'm going to replace what's inside of there with a 3. Integrate that with respect to y, that becomes 3 times y, where y goes from 0 to 2, so that becomes 3 times 2 minus 3 times 0, which is 6. And we're happy because it's the same number. Now, on the one hand, you might think to yourself, this is a waste of time. I already knew the answer was 6. But keep in mind, this region that we used is very simple. It's a perfect square. But we're going to end up talking about functions that are not nice and neat, and regions that don't have simple formulas to find the area. So if I asked you to find the area of this shaded region that I have down here, you might be at a loss. But now that we have these double integrals, we'll be able to do that. We'll first have to learn how to integrate over general regions, which is what we're going to learn in section 5.2.